All right, today we're going to be going over arithmetic sequence and how those work. This is set 4.6 in your green book. So we're going to skip 4.5 and we're just going to go straight to 4.6. So 4.6 in your green book, we're going to do arithmetic sequences. Now, what is an arithmetic sequence? Well, the word arithmetic, think about that. The most basic arithmetic is when you add or subtract something. So if you think about it, basic arithmetic is counting 1, 2, 3, 4, 5. What are you adding each time to get to the next number? If you start at 1, go to 2, from 2 to 3, 3 to 4, 4 to 5, what are you adding each time? You're adding 1. So the most basic arithmetic sequence is when you add 1 every single time and you just keep counting. That's why we call it arithmetic, is you're adding that value, same value, 1, every time. That's how we get integers. Now you could go the opposite way and subtract integers. So if you started at say 10 and you wanted to work your way back to 0, how would you do that? Going by ones. You would subtract 1 from 10 to 9, 9, 8, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, right? And you'd subtract 1 each time. So that's what we're talking about when we're talking about arithmetic sequences, is that we're adding or subtracting a constant value, the same value, over and over and over again in order to get the next value. The points will create a line. So in other words, if we say, hey, this is going to be A1, A2, A3, A4, that's the arithmetic placement of 1, the arithmetic placement of 2, the arithmetic placement of 3, the arithmetic placement of 4. And as I do that, I'm saying, all right, the arithmetic placement of 1 is the first time I place it is going to be at 2. Then I'm going to go to 5, then 8, then 11. These become our y values if you think about points on a Cartesian plane. The x values are going to be these points up here, okay? Those are really just the placement values. So the first term is 2, the second term is 5, third term, fourth term, so forth. All right, now, here's what we're doing. When you're looking at an arithmetic sequence, you're trying to find what is the common value you're adding. So if you think about that, how do I go from 2 to 5, 5 to 8, 8 to 11? Again, how am I going from 2 to 5? By adding or subtracting, not by multiplying, not by dividing. By adding or subtracting, how am I going from 2 to 5, 5 to 8, 8 to 11? You're adding 3, right? So every single time I'm adding 3. If you think about that, 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11. And then it says, what would the next 3 terms be? That's the next question it's going to ask. What will the next 3 terms be in this sequence? Well, that's pretty easy. If I'm at 11, all I've got to do is add the same constant value I've been adding all along. Just keep adding 3. So the next 3 terms after 11 would be 11 plus 3, which is 14, 14 plus 3, which is 17, and 20 plus 3, which is, 17 plus 3, which is 20. Now, the big issue is why we might need an equation and what the equation would be telling us. Well, what we need an equation for is to find ones clear out there, like the 25th terms in this sequence. So remember, the fourth term is 11, but I want to go clear out there and find the 25th term. Well, we figured out an equation for this, and this is what needs to go in your notes. And the equation is a sub n equals a sub 1 plus n minus 1 times d. So anytime you have an arithmetic sequence where you're adding a constant value over and over again, this equation is what we're going to use to find terms that are clear out there, like the 25th term, the 50th term, the 45th term, the 49th term, the 41st term, whatever. Okay, so I'm going to write an equation so I can get out there. Now, could I continue to add over and over and over again 3 until I hit the 25th term? You could. In fact, on the ACT, that's what they're hoping you'll do because it's a time waster. If you know how to write the equation, you won't waste that time. You'll simply write the equation and then plug in a sub 25 to find the 25th term in the sequence. So that's what we're going to do next. We're going to write an equation to find the nth term in the sequence. To do that, it's very simple. You take a sub n, wanting to find the nth term in the sequence, it will always equal the first term in the sequence y value. So the first term in the sequence value is 2 plus n minus 1. That's going to be constant. It's always going to be n minus 1 times the common difference, the value that you're adding over and over and over again, 3 in this case. This is the equation. From this equation, I can find any term value in the sequence. If I want to find the 25th term in the sequence, I simply plug in 25 for a sub 25. I want to find the 25th term in this sequence. What is the 25th term? Well, it's 2 plus 25 minus 1. Now, where did that 25 come from? It's because I'm finding the 25th term. So whatever this is, you're just going to subtract 1 from it, times the common difference of 3. So 25 minus 1 is 24. 24 times 3 is 72. 72 plus 2 is 74. 74 is the 25th term in this sequence, and I would be done. Now, I could go through and write it all out, right? 2, 5, 8, all the way till I've written out 25 of these suckers, and I've got to 74. You don't want to do that, okay? Let's find, for example, the 45th term. Once I have the equation, I can find any term I want. If I want to find the 45th, that's fine. 2 plus 44, how did I get 44 there? It's 45 minus 1. That's how I got 44, times 3. And I can just do that on a calculator. I'm going to go 44 times 3. That's 132. And then I'm going to add 2, which is the first term. The first term doesn't ever change. And I end up with 134. That is the 45th term. If I kept going and I went to the 45th term, the 45th term in this sequence would be 134. So I can find any term in the sequence I want using this equation. It's a very simple equation. Take the first term plus n minus 1 and then times by the common difference, the common value we're adding each time or subtracting. Okay? So on problems 1 through 6 in your workbook, I want you to do just that. I want you to write the next 3 terms just like it says. But I also want you, okay, as part 2 or part B to each question, find the equation to find the nth term. And then on the third one, or the third part of each problem, or part C if you will, find the 30th term in the sequence. Okay? I'm going to do number 2 out of your workbook with you. So get in your workbook, set 4.6, the extra practice there. I'm going to do number 2 with you. Number 2 says that I've got 20, 14, 8, 2, and then it goes dot, dot, dot. And it wants to know what are the next 3 terms. Then I want you to tell me what is the equation to find the nth term in the sequence. And then I want you to tell me what is the 30th term in the sequence. So we're going to do all those on all the problems 1 through 6. I'm doing number 2 with you. So here's number 2. The first question you always want to ask yourself is this. What is the common difference? How am I going from 20 to 14, 14 to 8, 8 to 2 by either adding or subtracting? You can't multiply or divide. You can only add or subtract. How did I get from 20 to 14 by adding or subtracting, 14 to 8, 8 to 2, that is the same thing every single time, the common difference? So how did I get from 20 to 14? You subtracted 6. How did you get from 14 to 8? You subtracted 6. So forth, so on. Now what if you didn't see that right away? How could you figure it out? Well, it's really easy. Take the second term, subtract the first term. It works every time. If you look up here on this first one, that one was easy to see, but think about it. You would do 5 minus 2. What would 5 minus 2 be? 3. That's my common difference. So if I take the second term minus the first term, it will always give you the common difference. 14 minus 20 is negative 6. Now a lot of you are just going to see it anyway. You're going to say, oh yeah, I'm minusing 6 each time. Okay, So that's easy to get the next three terms. That's the first step. I'm going to start at 2 and I'm going to subtract 6. 2 minus 6 is negative 4. Negative 4 minus 6, negative 10. Think about a number line. Negative 10 minus 6, so I'm going in a negative direction, still 6 more on the number line, puts me at negative 16. Those are the next three terms. Those are pretty easy to answer. But now I want to write an equation to find the nth term in the sequence. So I'm just using the same equation up here. Again, this is the one that better be in your notes. A sub n equals a sub 1 plus n minus 1 times d. I'm just going to sub in the values. The first term is 20. So a sub n equals 20 plus n minus 1. That's part of the equation, depending on which term we're finding. And then we've got to multiply by the common difference, the amount that I'm adding or subtracting each time. In this case, I'm adding or subtracting 6 each time. I'm subtracting 6. So that becomes my common difference. You'll notice I like to put the common difference in a parenthesis to remind me to multiply it to whatever this n minus 1 is. Well, in this case, I want to find the what term? The 30th term. So I want to do a sub 30 equals 20, that's the first term, plus 29. How did I get that? 30 minus 1 times the common difference, negative 6. 29 times negative 6 is negative 175. You can do that on your calculator. Then I add 20 to it. That's going to give me negative 155. That's the 30th term in this sequence. You're going to answer all three of those. So I'm looking for the next three terms. I'm looking for an equation to find the nth term in the sequence. And then I'm looking for the 30th term in the sequence for all the problems 1 through 6. So you should have three answers, the next three terms on each one, then the equation, then the 30th term for problems 1 through 6. Okay? Let's move on to the next questions, and I'm going to do number 9. Now this is ones that want you to graph it, and I think this is like number 7 through 15 or so. Might be 7 through 13, I can't remember. Anyway, you're going to want to graph it. And what it's going to give you is just a series of numbers. And you're going to say, well, wait, how am I going to graph this on a Cartesian plane when I only have one set of values? I need two. I need x's and y's. Well, the x values are the term placement of each and every term. In other words, the first term is 15 halves. The second term is 13 halves. Third term is 11 halves. Fourth term is 9 halves, and it would keep going in that same type of situation. Now, how do I mark it on a graph then? Well, I simply mark 1 being the x value, being the first term, and 15 halves. Now, where is 15 halves? Well, you can do it on a calculator and get a decimal value, or you can just think about it. 2 goes into 15 7 times with a half left over, so I'm going to go up 7 halves. So that point is 1 7 halves, or 15 halves. So if I went up 15 halves, or 7 halves, 7 and a half, sorry, that's where I would be. So I'm at 7 and a half there. Where would I be at 2? Well, that's 13 halves. What's that? Well, think about it. 2 into 13 goes 6 with 1 left over. That's 6 and a half. So 2 is at 6 and a half, 3 is at 5 and a half, 4 is at 4 and a half, and it just keeps going down by 1 each time. So think about what the slope is here. I've gone down what and over what every single time. I started at 7 and a half and I went down to 6 and a half. How far down did you go? 1, right? And you went over to the right 1. So think about this. This slope is negative 1 over 1. That's really the common difference. You're subtracting 1 each time. Now, if you think about that, if I had 15 halves minus 1, what would that give you? Well, I would need a common denominator. Put it as 2 over 2 times that by 2. 15 minus 2 would be what? 13 halves. Have you seen that before? Yeah, that was the second term. If I took 13 halves and minus 2 over 2, or minus 1, what would I get? 11 halves. If I took 11 halves and minus 1, which is 2 over 2, I'd get 9 halves, and so on and so forth. So I'm going down 1 and over 1. Subtracting 1 is my common difference in that sequence, and that's how come it looks like a line. Okay, I'm going to let you try the rest of those on that section. Let's flip the page over, and you'll go to the next section, and this is number 16. Now on these, it's much like we were doing before, only there's only two parts to this question. They don't want you to necessarily give the next three in order. They want you to write the equation, and then they want you to find it doesn't say to find any term, but I want you to find the 21st term on all these problems. So I don't know which ones I'm on. I think I'm on like 14 through 21, something like that. Okay, and you're going to be writing an equation to find the nth number in the sequence, and then I want you to tell me the 21st number in the sequence. Okay, so to do that, again, I have to think, well, how am I going from negative 5.4 to negative 6? This is number 16. How am I going from negative 5.4 to negative 6.6 to negative 7.8 to negative 9? What are you doing each time? Now, some of you can just look at it and see it and say, oh yeah, I'm subtracting 1.2 each time. If you don't see it right off the bat, remember, you can always just take the second term and subtract the first term. Now remember, you got to do your signs correctly. Subtract a negative 5.4. Subtracting a negative means I add, so take negative 6.6 on your calculator and add 5.4. That will give you the negative 1.2. So if you take the second term minus the first term, that'll always give you the common difference. Then you just have to verify it and check that that's still what you're doing. To go from negative 6.6, did I subtract 1.2 to get to negative 7.8? Yeah, that's exactly what you did. So negative 1.2 is the common difference. Now I'm ready to, once you have that common difference, you're ready to write the equation. A sub n equals the first term, negative 5.4, plus n minus 1, that's just the constant that's part of this equation, and then times negative 1.2. Now how did I get negative 1.2? Well, that was the common difference. Now I just plug in any term I want. Now I asked you for the 21st term, so I'm going to plug in 21 for n. Well, n being 21, 21 minus 1 will be 20. 20 times negative 1.2 gives me negative 24. And then I'm going to add negative 5.4. So think about a number line. I'm at negative 24. I'm subtracting 5.4 more. I'll end up at negative 29.4. Okay, go to number 22. Number 22 says you're in this auditorium, much like our auditorium, and the first row of seats has 30 seats in it. Okay, so if you think about that, here's our first row of our auditorium. There's 30 seats across, right? There's all the seats in the first row. There's 30 of those across. Then the next one, we're going to add 4 more, so it's going to be a little wider, and if you think about the auditorium, it is. As you go back, this next row is a little wider. I don't know that they're adding 4 seats, but this one tells us we are. So we're going to add 4 seats to this next row. So the next row would be 34 seats. And then the row after that would add 4 more seats and be 38 seats. So we're continually adding 4 more seats. Well, that tells you the common difference. Common difference here is 4. I'm adding 4 more every time. The first row of seats is 30, so that's your first term. Okay, so it's really easy to write the equation. A sub n is 30 plus n minus 1 times 4. Well, how many rows are there in this auditorium? Well, there's 25 rows in the auditorium, which means how many seats are in that last row? That's what the question's asking. So I'm going to plug that in. 30 plus 24. How did I get 24? 25th row. So it's 25 minus 1, 24 times 4. 24 times 4 is 96, plus the 30 seats in the original row, and we end up with a total of 126 seats in that 25th row. So 126 seats in 25th row. And that's number 22. Okay, I'm going to let you try the rest of them on your own. I'm sure Kate has seen this and can answer any questions that you may have. Thanks.